Now we start with theorem. But what is theorem? Some properties are proved logically called as the theorem. And our first theorem is basic proportionality theorem, that is BPT theorem. Statement is, if a line parallel to a side of a triangle intersect the remaining side in two distinct points, then the line divides the side in the same proportion. Now we prove this theorem. First of all, we draw the diagram. Diagram is very important to prove the theorem. In this theorem, we first draw the diagram of the triangle. If a line, first we draw the triangle ABC. A line is parallel to the one side of triangle, so we first draw the line which is parallel to BC. Line L parallel to BC. If a line parallel a side of a triangle intersect the remaining other sides in distinct 2 points, that is P and Q, then the line divides the two sides AB and AC at the same proportion, that is AP upon PB and AQ upon QC. If statement is our antecedent, that is the given part. If statement, if a line parallel to a side of triangle, so we take if in triangle ABC, line PQ parallel to side BC and line L intersect side AB and AC at distinct point at points P and Q respectively. This is our given. Then part is our consequent, that is to prove that theorem. Then the line divides the side in same proportion. This line L divides the two sides AB and AC in proportion, that is in equal ratio. So we write AP upon PB equal to AQ upon QC. This thing has to be proved. Construction. Join PC and BQ. Join PC, segment PC and segment PQ. Now proof. In triangle APQ, this small triangle APQ and triangle BPQ, both the triangles have equal height because they have common vertex. Both triangles have equal height. So, ratio of area of two triangles with equal height is equal to ratio of their corresponding bases. Area triangle APQ upon area triangle BPQ equal to, these two triangles have common vertex, so height is equal, so ratio in the proportion of their bases AP upon PB. Areas proportion to corresponding bases. Also, and in triangle APQ and triangle PQC. Now this side APQ and PQC. P is the common vertex now. So height of these two triangles are also equal, have equal height. So area triangle APQ upon area triangle BPQ equal to height equal. So ratio of area of two triangle is equal to ratio of their corresponding bases, that is AQ upon QC. Number 1 and this is number 2. Now in triangle BPQ and triangle both have common base BC. BC is their common base. PQ is their common base. And PQ parallel to BC. So height of triangles are equal. Area triangle BPQ equal to area triangle PQC. Both the area of these two triangles are equal because they have common base PQ and equal height. So these two areas are equal. Give them number 3. Look at equation 1, equation 2 and equation 3. Numerator APQ, denominator triangle BPQ, triangle PQC, but in our third case these two areas are equal. So we write area triangle APQ upon area triangle BPQ equal to, these two ratios are now equal. Area triangle APQ upon area triangle PQC. Number 4. So these left hand side are equal, so right hand side also equal. So AP upon PB equal to AQ upon QC. And this is who our to prove is proof. We learned some property of triangle. Now we study the property of an angle bisector of a triangle. First theorem is the bisector of an angle of a triangle divide the side opposite to that angle in the ratio of remaining side. First of all, we draw the triangle. We draw the triangle ABC. We draw the angle bisector of angle C. So given part is in triangle ABC, bisector of C, intersect AB at point E. To prove that the side opposite to that angle are in the proportion to remaining two sides, that is AE upon EB equal to AC upon BC. To prove this theorem, we need some construction. Draw a parallel line to CE. To draw a parallel line to CE. CE ला parallel line काढायची आपल्याला. To draw a parallel line to CE. Passing through point B. Extend AC at point D. Intersect at point D. ACE, CE parallel to BD, and AD is transversal. So angle ACE and CDB, these two angles are corresponding angle, and corresponding angles are equal. ACE congruent angle, equal angle CDB, that is number 1 corresponding angle. Now we take BC as transversal, CE parallel to BD, take BC as a transversal, BC is transversal, these two parallel lines, and BC is transversal, so there is alternate angle, pair of alternate angles are equal. So we take angle ECB, congruent angle CBD, alternate angle, pair of alternate angle. This is equation number 2. Now given CE is an angle bisector, so these two angles are equal. So angle ACE congruent angle ECB, number 3, that is given. CE is an angle bisector, so these two angles are equal. From 1, 2 and 3, observe 3 equations. ACE congruent to CDB, ECB congruent CBD, so, and third ACE congruent ECB, these two angles are congruent, so these two angles are also congruent. So angle CDB congruent angle CBD, equation number 4 from equation 1, 2 and 3. Now these two base angles are congruent. So in triangle CDB, these two angles are congruent. So and opposite sides are also congruent. So side CD congruent side BC, side opposite to congruent angle. So we write CD equal to BC, equation number 5. Now we use BPT theorem. In triangle ABD, CE parallel to BD. So we use the BPT theorem. By BPT theorem we write AE upon EB equal to these two, AE upon EB equal to AC upon CD. This is equation number 6. Now we have to prove AE upon EB equal to AC upon BC. So we change the CD with